Okay, this is for 7.7, factoring the difference of two squares. So you need to have your book, of course, and you need to have your note paper. So 7.7, factoring the difference of two squares. So in the example, we talk about we have x squared minus 25. I want to remind you, remember our format, our typical ax squared plus bx plus c, to where that's our standard form of trinomial. And remember, a, b, and c are all numbers. So they're like integers, or they're numbers. Now I want you to look back at our original problem here. X squared minus 25. Well, what's the a term? So your a term is 1. What's your b term? Notice there is no x. So b, in order to get rid of the x, the b had to be 0. So our b term is 0. Our c term is negative 25. So if you think about this, you're thinking, now notice this a term is 1. So you're thinking, so x squared, I'm just going to put it down here, x squared minus 25. So this a term is 1. So what you're thinking about here are what two binomials multiply to get x squared minus 25. So we know this is going to be x and x, but then really you're looking for two numbers that multiply to get 25, but add together to get 0. So you can even think about that A, C, B. Some of these you don't have to do because you're going to start noticing a pattern very quickly. You're saying that a times c, which is a negative 25 x squared, you're thinking, and your b was a 0x. That's a negative. So if this is a negative 25, you know one of these are going to have to be negative. One's negative and one's positive. But what numbers multiply to get 25 but add together that are like add together to get 0? Or that are 0 apart? Well, the only numbers that are 0 apart if it's the exact same number. So this is going to be a negative 5 and a positive 5. And remember before when we foiled this, when we distributive or foiled, that middle term was missing. So we call this the difference of two squares. So the difference is you're subtracting, and the two squares. Well, let's look at what our square numbers were. Our numbers were 1 and our numbers were 25. Those are perfect squares. So think back to your perfect squares. So your perfect square numbers, and if you're in the classroom doing this, you can look up at the wall and see the chart, but remember their perfect squares are 1, 4, 9, 25, 36, 49, 7, 8, 64, 81, and so forth. So it's nice when they're perfect squares, and it's the difference of perfect squares. Okay, so let's do another one. X squared minus 36. Well, that's the difference of two perfect squares. So what's nice is that, okay, so it's x, that's a negative, so that has to be a negative and a positive, and it doesn't matter if you put plus here first and then minus, or a negative here, that's fine, but that's going to be 6. Well, you can also then FOIL this out to make sure. But let's do one that doesn't have a 1. Let's do 16 x squared minus 49. Well, you could do the ACB method. That would work. But then notice this 16 is a perfect square, and so is 49. So what's nice about it is that that's going to be 4x, and there's no middle term. The key to this is there's no b term here at all. So 4x minus 4x plus, and then it's going to be 7 and 7. And then this has to be opposite because you have to get rid of that middle term. So if you FOIL this, you notice that that middle term's gone. So this actually goes pretty quickly if you can recognize that they're perfect squares. You might have to, I can see this happening, maybe that's 32 and what is that, 98? If you divide by 2, then it'd be 16 and 49. So sometimes I always look to see if there's a greatest common factor. If not, then I look to see if there's perfect squares and then the difference of those perfect squares. So hopefully that helps there. The second thing you're going to see, is problems like this. So this is example 3. When you have n squared plus 8n plus 16. Now this you can still think the same way. This a is 1, so you can still think about n and n. What you think about those, what times numbers multiply to get 16 but add to 8. And you notice, okay, so that's going to be 4 and 4, and that's positive, so you're still going to have both of these as positive. So what numbers multiply to get 16 but add to 8? Well, it's going to be n plus 4 times n plus 4. A faster way to write that is n times 4 squared. And do you remember when I gave you this problem earlier that you do not do this? And that's what a lot of you did. You just said, okay, I'll just square this, square that, and that's it. Well, when you FOIL this, that means n plus 4 times n plus 4, and when you FOIL it, you get a middle term. So when you have n plus 4 squared, that will have a trinomial. You'll have a middle term. So something like this. 4x squared minus 12x plus 9. Well, again, these are perfect squares. Now, these were perfect squares too. There's a 1 there. So 1 and 16 were perfect squares. 4 and 9 is a perfect square. So what you can do here is say, okay, that's going to be 2x and 2x. You're taking the square root of those two. 9 is going to be 3 and 3, but it has to add together to get 9. No, excuse me, multiply to get a positive 9, add to get together to get a negative 12. So it's going to be the same thing, just squared. Now, another way you could do this is still do your ACB. That method will always work, no matter what type of problem it is. So you could still do that ACB to where you're saying 36a squared minus 12, or x, I don't know where I'm getting my a, negative 12x. So you could still do that method. Don't think you have to change. But one other method you can do is the 2x minus 3 squared. Okay? And, okay, last one, example 4. I'm trying to do this a little fast. I hope it's not too fast for you guys. If you have a problem like this, look at example 4. X squared plus 2/3 x plus 1/9. Don't freak out about these fractions, and do not change to a decimal. You hear me say that all the time because this is a repeating decimal. You don't have terminating decimal here, so don't change it to a decimal. But think about your equations that we've done with fractions before. What is one of the ways you can clear the fraction? What's one way that you can get rid of these denominators? I hope you're all yelling, not yelling, but I hope you're all saying, good. Find a common denominator, find the least common denominator, and clear that out. So if I notice I want to get rid of the 3 and the 9, so the lowest number they both go into is 9. 27 is 1 too, but then you have to do reducing. But 9. So what I can do is you can multiply every single term by 9. The thing is, you have to do it to every term in the entire equation to make it stay equal. Now, it was 0, it's still going to be 0, but let's say that was another number. Let's say it's 5. If you clear this out, you also have to multiply that number by that, whatever you multiply these by 2. Don't forget you're going to have to multiply that. So what I like to do is I do this whole thing. So I'm distributing a 9 to each term. So this is going to be 9x squared. 9 and 3, that cross reduces, so that's going to be 1, that's going to be 3. 3 times 2 is 6x. 1/9 of 9 is 1. And then don't forget the 9 here. I know that's 0, but typically what happens if that's like a 5, people will forget that. So don't forget that 9 times whatever that number is too. Now you can go through. Now these are perfect squares. 9's a perfect square, 1's a perfect square. So you still can do the AC method, the ACB method. That'll work. If you want, 3x, perfect square is 1, perfect square is 1, and then these are both positive, so that should work out to that's equals 0. Now the only answer, this is going to be, remember you're looking for what x equals to make that equal 0. X is going to equal a negative 1/3. Because remember I had 3x plus 1 equals 0. Subtract 1. Whoops, that's 11. Subtract 1. 3x equals a negative 1. X equals a negative 1/3. So a negative 1/3 is the only thing that you can use to make that 0. So doing this helps alleviate any type of guess or check and all that craziness. So that is what 7.7 is going to be like. And I can't even remember what the assignment was. 7.7. Okay, 3 through 8 all. I'm sorry, guys. I should have looked at this before making this video. No, that's going to be practice 15 through 20. That's going to be good practice. 25, 26. Good practice. 27 through 39. Odd. Okay. 41. Okay, I'm going to do you a favor. 41 to 43, I'm going to let you skip those. You can take off the 41 through 43. So still do the 7.7, all of these, and you have it done by Monday. I know that's a lot, you guys, but we're getting down to the wire on getting things done and making sure you have practice with it. So I do want you to really practice all those. This 7.8 is not going to be too bad because you've already actually been doing it. So we'll be I'll be cutting this down a little while too. Okay, thank you guys. We will see you next week.